I am going to construct a parallelogram and explore its properties using the geometrist sketchpad. First, I'm going to draw a line segment and then another line segment. Next, I want to draw a line parallel to AC passing through the point B. I select the point B and the line AC. Under the Construct tab, select Parallel Line. A parallel line is displayed, and I click anywhere on the white space to deselect it. I want to draw another parallel line, parallel to AC, parallel to AB, passing through the point C. So I select this point C and the line AB. Then under the Construct tab, I select Parallel Lines. I click anywhere on the white space to deselect the line. Then I select the Line tool and the first option. I draw a line segment from C to this point. Again, I click anywhere on the white space to deselect that line, and I select the Line tool to draw another line segment from point B to this point again. So again, I click on the white space to deselect that segment that has been drawn, and I label this new point of intersection as D. I have to hide the dotted portions of the line. So I click on the dotted line, and under the Display tab, I say Hide Parallel Line. Similarly, I click on this dotted line, and under Display, select Hide Parallel Lines. I have constructed a parallelogram, and now I'm going to proceed to measure the lengths of the sides of this parallelogram. AC is 1.90 inches. Sorry, I moved the figure. Just now you saw a little move, so what I do is I'm going to go into Edit and say Undo. Right. This is what I normally do to correct mistakes. So when I click on B, D, and then I select Measure Distance, and you see BD is also 1.90 inches. Then next I'm going to measure CD, and CD is 3.42 inches. Measure AB, it is also 3.42 inches. I am going to proceed to measure the angles inside the parallelogram. First, I'm interested in measuring angle CAB, and it is 27.13 degrees. Next, I want to measure angle BDC. It is also 27.13 degrees. Let's mark it. The next angle I want to measure is angle ACD. And angle ACD is 152.87 degrees. Next, measure angle ABD. And that is also 152 degrees, 152.87 degrees. We see that the interior opposite angles inside a parallelogram are equal. So we have these two angles equal and the other two opposite angles equal. They all add up to 360 degrees. The angles inside a parallelogram add up to 360 degrees. If you add up these two angles, angle CAB and angle ACD, you add them up, you will get 180 degrees. I am now going to proceed to draw the diagonals of the parallelogram AD and the other diagonal CB. Then I'm going to mark the point of intersection. between the diagonals. It's marked as point E. I'm going to measure the length of AE. And the length here is 2.59 inches, AE. Now let us measure ED. It is also 2.59 inches. CE. And we're going to measure the distance between C and E, so it's 0.97 inches. And similarly, we measure the distance between E and B, which is also 0.97 inches. We see that the diagonals of a parallelogram cut each other at one point, and it divides each other into equal halves, so that AE is equals to ED and CE is equals to EB. They do not intersect at right angles. If I indicate an angle here like this, you will see that it's not a square, it's not a right angle. So they do not intersect each other at right angles, but they intersect each other at one point, and then they cut each other into equal halves. Now I'm gonna explore this parallelogram further by picking one point like this B here, and then I try to move it. And I try to scale this parallelogram, and you can see the way the numbers move. The two opposite angles are always equal, so that angle ACB is always equals to angle ABD. The two opposite angles are always equal. And you can see from the movement of the numbers here that the diagonals are always cut and intersect each other, and then they cut each other into half. AE is always equals to ED, CE is always equals to EB. This is the end of my presentation. Thank you for watching.